Assalamualaikum. My name is Ahmad Syakir Iman bin Muhammad. My metric number is AE210029. Today I want to present the introduction. Uh, in, okay, we start with Ohm's law discovered by a German physicist Samuel. Is an important law that describes the relationship of voltage V to current I and resistance R. It is often referred to as the foundation of circuit analysis and can be expressed by three different ways. Firstly, we can express by I equal to V over R. Second, V equal to IR. And last one is R equal to V over I, where V is the potential difference for one end of a resistant element to the others involved, where I is the current through the same resistant element in amperes, where R the resistance of the same element in ohms. Remember that lowering the resistance raise the current and raising the voltage. DC power is determined by equation P equal to E multiplied by I. For Ohm's law, the power equation are P equal to I square multiply R and P equal to E square over R. From three power equation above, DC power can be determined by using at least two parameters from three parameters. Those are I, E, and R. So DC power can be obtained from DC ammeter and DC voltmeter. The obtained power for 9 DC meter is more accurate than voltmeter obtained. And DC meter will use less power from the circuit. And DC meter connection is shown as figure 1.0. During the both ohmmeter and meter will use same power of the circuit. Apparent power in the circuit may be not accurate. Measuring voltage and current separately leads the accurate value, such as measure voltage by using voltmeter first and remove the voltmeter from the circuit. After that, connect ammeter to measure current passing load. Okay, next I will present the method. For activity 1, firstly we need to conduct a circuit simulation by use any suitable software, such as Proteus, Multisim, PSPice, or MATLAB. Next, we need to supply DC voltage connect to 10 volt to a circuit as shown in figure 1.1. Next, the current I1 and voltage U1 for the 100 ohm resistor measure using voltmeter with an internal resistance of 10,000 ohm. Then the result written into table 1.1. Next, R1 modify as mentioned in table 1.1. And number 6, the resistance RT compute and the result enter in table 1.1. The percentage relative error compute and the result record in table 1.1. This is table 1.1. So for next activity 2, circuit simulation conducted by using stable software. Next, the circuit as shown in figure 1.2 was set up and DC voltage supplied to 10 volt. The current I1 and voltage U1 for the 100 ohm resistor measure the ammeter internal resistance RA of 15.5 ohm was used. The result record in table 1.2 and R1 modified according to table 1.2. The resistance RT calculate and the result record in table 1.2. Resistance R1 calculate and the result record in table 1.2. The percentage relative error calculate and the result record in table 1.2. This is table 1.2. For RTT 3, firstly we need to conduct a circuit simulation by use any suitable software. This is the second. Next, we need to connect the circuit with supply DC voltage of 10 volt. The internal resistance of emitter RA 15.5 ohm was used. Next, we need to measure the emitter and record in table 1.3. Then we need to record I1 for circuit. Calculate the result record in table 1.3. Percentage relative error calculate and result record into table 1.3. And step 3 is repeated by using resistor as specified in table 1.3. This is table 1.3. Next, the last activity is activity 4. We need to, as usual, we need to conduct a simulation circuit using the suitable software. The internal resistance of voltmeter times 10,000 ohm was used. The voltage and current measure the series measure the result record into table 1.4. The current measure and the result record into table 1.4. Next, the power from circuit calculate and the result record in table 1.4. Step 5 is the power from voltage and current reading calculate. The result record into table 1.4. Power loss in voltmeter calculate and the result record into table 1.4. Percentage relative error calculate, the result record into table 1.4. Last one, the load values change into table 1.4. Step 1 to 3 repeated and the result record into table 1.4. This is table 1.4. This is all for me. Thank you.
Warahmatullahi wabarakatuh. So my name is Ali Faikal. So I will presenting about the question about the experiment. So there are a few questions about the experiment. We have 12 for the DC and one question for the AC. So the question is about we need to compare the measured value and calculated value based on activity 1, activity 2, and activity 3. That is for AC experiment, AC voltage. So for the DC experiment, we need to explain the result based on the activity that we have been conducted. So we had to explain the difference between the measured and calculated value. So we need to explain the error, the table, and the function, and the power losses. So they are all the question that we need to perform, like question that we need to solve for the experiment. So I able to. So that is for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Solihin bin Azlan, metric number AE210030. So today I will present about lab exercise 1 for activity 1 until 4 for DC measurement of resistance using multisim software. So first of all, we look at the instruction at the lab sheet. So the circuit diagram for DC meter connection given is like this. We have one voltage source, one ammeter, one voltmeter, and one resistor. So go to the multisim. And then how to find for the component is right click and choose place component and just search for what component that we want to use. For example, ammeter. There are many types of ammeter, and then voltmeter, and also for resistor, go to basic and search resistor. There are many types of resistor, and ground component, ground here. Okay, after we finish find all of the component, we need to connect each of the component, connect the circuit. So after connect the circuit, just run it, but don't forget to change the value of resistor based on the question given. So for 100 ohm resistor, the reading for ammeter is 0.101 and voltmeter is 10 volt. So that's how to use to simulate the circuit by using multisim. So for result, this is my result, our result for our group. For measured value and calculated value, by using the formula given in the lab sheet. So this is the value for measured value for resistor from 100 ohm until 1 kilo ohm for activity 1. This is for 100 ohm, this is for 150 ohm, 200 ohm, 300 ohm, and 1 kilo ohm. And then for activity 2, so before that, this is for the hand calculation for activity 1 to find RT, R1 and 100 and percentage of relative error. So this is the value for, this is the result for measured value and calculated value for activity 2 and calculation for activity 2 to find RT, R1 and also percentage of the relative error. Same goes with activity 1. And then for activity 3, the value for I1 from the circuit using the formula given, I1 reading, I1 measured, and percentage of relative error. And this for activity 4. Each activity have different arrangement of the circuit, but by using the multisim, the step is still the same. So I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Bahaki Biosozaki and my metric number is AE210034. Today I would like to discuss about AC measurement of resistance, which is in the experiment 1 that we have conducted in the previous lab session. In the AC measurement of resistance, there are 3 activities that need us to do the hand calculation and also simulation, and then one activity contain question that we need to answer. Every activity have different types of circuit and also component, so we need to do the hand calculation and also run all these 3 activities and get the result of the current and also voltage. Now I would like to show you how we simulate the circuit, all the circuit of 3 activities using the multi-sim software. This is one of the example from the activity 1. First, what we need to do is we need to set up all the components needed in the circuit, such as for the circuit we need to have the AC voltage, the load, and also the ground. And then after we complete the circuit, we need to put the voltage measurement and also current measurement to get the answer. And then after we complete, we can run the circuit to get the result. Okay, this all the results stated here, and the result that we need to put in the table is here, the IRMS and also VRMS. This is how we simulate all the circuit for the 3 activities. Then we go through all the result from the table. So for the activity 1, this is the result of the calculated value and also simulated value. For the different type of loads, first 200, 210 ohm, the calculated value and also the simulated value stated here, the 390 ohm and also 470 ohm, 860 ohm. And this is the hand calculation of the activity 1, and then this is the simulation of the activity 1. Then we go through the activity 2. All the result of the calculated value and simulated value are stated in the table here. First, this is the load, which is the combination of R1 and also R2. First, we each 210 ohm plus 390 ohm. Then the second 390 ohm plus 470 ohm. As you can see, the third one is 470 ohm plus 860 ohm. And also the last one is 210 ohm and also plus 860 ohm. Then this is the hand calculation for the activity 2. And then this is the simulation for activity 2. Next we go to the activity 3. This is calculated value and also the simulated value. And for the load for activity 3 is in parallel, which is R3 is in parallel with R4. The first one is 210 ohm parallel with 390 ohm. Second one is 390 ohm parallel with 470 ohm. Then third one is 470 ohm parallel with 860 ohm. And the last one is 210 ohm parallel with 860 ohm. And then this is the head calculation for the activity 3. And this is the simulated value for the activity 3.
Assalamualaikum and hi, my name is Ahmad Zairin Ali bin Yaakob. My metric number is TE220.03 and today I'm going to present about our group discussion and conclusion. So for our group discussion, the relationship between a circuit's voltage, current and resistance is known as Ohm's law in the analysis of DC circuits. It states that the voltage across 2 points and the resistance between them determine the relationship between the current flowing through a conductor between those 2 points. This law is frequently applied in DC circuit analysis to determine the current and voltage in circuit. Ohm's law can also be expressed as V equal to IR, where V is the voltage applied to the circuit, I is the current flowing through the circuit, and R is the resistance of the circuit. When analyzing a DC circuit using Ohm's law, the voltage and current are always measured across and through the component. In other terms, current is the movement of electric charge through a component, while voltage is the difference in potential between two places in the circuit. And to determine the power in a DC circuit, we need to measure both the voltage and current. This can be accomplished in multisim software by utilizing a voltmeter and a DC ammeter. A component's voltage is measured using a voltmeter, and its current is measured through a component using a DC ammeter. The power in a circuit is given by the formula P equal to multiplied by I, where P is the power in watts, E is the electromotive force in volts, and I is the current in amperes, so the power can be calculated. After determining the power in the circuit, it is important to compare the calculated and measured values after identifying the circuit's power. If the calculated and measured values differ, there may have been a measurement error. And by comparing the measured and calculated values, we can also identify any differences and modify the analysis accordingly. So moving on to our group conclusion. In conclusion, Ohm's law, which describes the relationship between voltage, current, and resistance in a circuit, is a fundamental principle in DC circuit analysis. This law is frequently applied in electrical and electronic engineering to design and analyze electrical systems and determine a circuit's voltage, current, and resistance. The understanding and applications of Ohm's law is essential for engineers and technicians working with electronic circuit. It offers a fundamental understanding of how electrical circuits work and how various components interact with each other. And next, Ohm's law also provides a foundations for more complex concepts and theories like Kirchhoff current law and circuit analysis method. Overall, Ohm's law is an important concept in the field of electrical and electronic engineering, and it has played a significant part in the growth and development of technology. Last but not least, Ohm's law and measurement instruments like voltmeter and DC ammeters can be used to accurately analyze DC circuits, which is important in many engineering and technological fields. So I think that's all from me. Thank you.